Hi there, my name is Rustybot. This tutorial focuses on taking any part of your avatar, such as, say, your hand or a screen, and being able to recall it using protoflux. So that if someone takes your object, rescales it, throws it off screen, you can just poke a little button and have it fly back where it's supposed to be. In order to start, we're going to create a new 3D model box, inspect that, and set the size of the mesh to 0.4 on both sides and 0.05 on the vertical. This is going to give us a nice little platform to work with. I'm going to make a new parent, and I'm going to take the grabbable component from that, move up to the box parent, drop it here, and hit move component. So now this whole thing is grabbable on its own. Rename box parent to object recall demo, at least in this case. And I'm going to make a new child of that called snap target. This is going to be the resting position of our main object. To get our main object, I'm going to make a copy of the box, set all of its transforms to 0.15, or sorry, all of its sizes rather. I'm going to reparent that under snap target and move snap target up by 0.1. So now that's resting on top, nice and pretty. Then I'm just going to take the original box, duplicate it one more time, set it to 0.05 on all sides, and use this part of the gizmo here to move it along the plane out in front. This is going to be a little button so that when we poke it, it'll recall our snapper object. Now I'm going to go to the recall demo, take the grabbable component, move it onto this box, and hit copy. So now this is grabbable separately, but you'll notice that it's still underneath the rest of it, which gives it some interesting behavior. So instead of just leaving it like that, we're going to go to attach component, hit transform interaction, and on this box, which I'm going to rename to object, we're going to put the snapper component, and that will interface with snap target component on the parent slot. So I'm going to add a keyword, box, and then snap target up here, add. I'm going to add another keyword, box, same thing. You'll notice this one comes with a collider. This sphere collider is the range within which you have to place this object so that it will snap into position. Now, the object itself can be taken and left out, and you'll notice that it's no longer within this hierarchy. It's actually directly underneath spawn area with me. So what I'm going to do is switch over to Flux, open up the node browser, and we're going to set up a little way to animate this cube. I'll put it back on the snapper, and we're going to go to Actions, Tween Value, and then down to Float 3. So a tween, which is short for an in-between, is an animation term, and this will let you animate a field. Important to note that you're not directly animating a slot, you are animating a float 3 value in this case. So we're going to take object, we're going to go all the way up and get the position field. And then in 2, we're going to set it to, 0.5. Then I'll make a call here. And so now when I call this, it's going to animate the position on object from blank, which means from wherever it currently is, to this coordinate. There we go. Set this back to 0, all the way back down. So you might understand that this is how we tween the position back. We're also going to need one for tweening the scale, because an object in a resting space should generally be at 1 scale on all sides. So I'm going to set that to be so. And then we're also going to scroll down a bit more and get the float Q version. So this is a rotation value, which means I can grab the rotation field and drop that in there. Just move this over. Put these here. There we go. Nice and aligned. Now tweens will output on started and they will output on done. So what that means is if I again set this to go up by say 0.4, I can click this and it'll pulse out the top when it starts and then the bottom when it finishes. There we go. Which means you can chain together a bunch of on-started outputs to a bunch of tween inputs and have an animation that happens all at the same time. So now if I set this to 0 and call that, it animates every field back to its default. What you'll notice is if I take the object and leave it outside of the snapper, then when I click this, it's going to fly all the way to origin. That's the center of the slot I'm currently under. So what we're going to need to do is go back out, go to slots, and do set parent. So this will let you take an input slot and a destination slot, meaning I can put the snap target in the bottom here and the object in the top. And then when I pulse this, it will parent this slot under this one, meaning you'll see that when I call that, it pops into there. I'm going to delete this call. And if we stick these together here, whoop, So what's happening is this is a regular call context, and tweens use async, which is short for asynchronous. So we're going to go to flow and up to async, and we're going to start an async task. Now, for now, just think of that as meaning you're telling your protoflux that whatever's coming out here might take some time to complete. It won't happen all in one calculation necessarily. We're also going to get a sequence, and I'm going to demonstrate with a delay updates. So an async sequence will take an input, and it will pulse out here, and then pulse out here, and then pulse out here. And that's nice, but the actual specialty of it is that it waits for the previous step to complete before pulsing the next one. Meaning, if I set this to 30, which means it will delay by 30 updates, which is pretty much 30 frames, then I can click this, and you'll notice that after this outputs, or rather after this outputs on triggered, this will wait for the delay. This one will only trigger once the delay is complete. There we go. So on triggered happens first, and then the delay, which allows the next few steps. So what we're going to use that for here is setting the parent and then doing the animation in order. Now, starting an async task would allow you to convert a non-async context like this one into an async context, and it would work fine. We're going to use that in a moment to connect our button. So instead of this call, I'm going to have an async task going in there. Then we're going to set parent, set animation, and now clicking this will bring our block back, even if it's outside of its parent object. There we go. Now you'll notice the rotation being a little bit jittery. That's because there's an interesting bug with some of these inputs right now. So just plop any random number in there and then zero it out, and it'll work fine. So instead of this call, we're going to go to interaction, button events, and have that be our input to the circuit. Then we're going to go to the lower box we made a second ago and put a touch button on it. Now grab this component and drop it in here. So if I take the cube and then press this, it flies back. Last thing you'll notice is that if I'm holding this and it flies back, that's fine. But when I let go, bad example. Here we go. But when I let go, the inspector flickers for a moment. That's because what's happening is I'm dropping this object and it's parenting it wherever I am. It's putting it back under spawn area with me. So when I call that back and then let go, it checks to see if it's supposed to be under spawn area and realizes, oh, it's within the snapper, so it actually puts it there. But that means that if I let go of this while it's flying, it ends up back at root because I let go of it, so it drops it back where I just picked it up from, effectively undoing this step, which means that instead we're going to have to go to components, set component enabled, and before even setting the parent, we're going to have a reference here to, on the object, the grabbable component, and a Boolean for whether or not we want to turn it off or on, and a call. So what this will let me do is use flux to change the enabled state on the grabbable there, or if this is true, it sets it back to true. So in this case, we're going to set it to false, and then have another one of these at the end of the circuit that sets it back to true. And then just hook these up to the async, so I'll make a new step, make that the first step, set the parent, then play the animation, then it will wait for the animation to play before setting the grabbable re-enabled. So now I can recall this, it flies back, I can hold this, it flies back, let go, nothing happens. And even if I let go while it's flying, it's fine. So for the final step, we're just going to make a new slot under the recall demo. Call that scripts. I'm going to select all of this with secondary, grab scripts, and in my radial menu, hit hack into. Now I can put my tool away, and we have a perfectly functional little snapper object. No matter what I do to this cube, except for deleting it, I can press this button and it'll fly back. This object, and any others that I make during this tutorial series, are going to be made available in my Resonite public folder, which you can get by pasting the link in the description directly into the Resonite platform. Later.